This video is Hypothesis Testing Full Examples Part 3. We're starting with Example 8, Spam. According to Message Labs Limited, 89% of all emails sent in July 2010 was spam. A system manager at a large corporation believes that the percentage at his company may be 80%. He examines a random sample of 500 emails received at an email server and finds that 382 of the messages are spam. Using a significance level of 0.05, can you conclude that the percentage of emails that are spam differs from 80%? Okay, so let's find our claim that we're testing. Can you conclude that the percentage of emails that are spam differs from 80%? Okay, so first we need to write our null and our alternate statement. So first we have to decide, what are we testing? Are we testing a mean or a proportion? Well, they said percentage, so I guess we're testing a percentage, but a percentage is just a proportion written in percentage form. So we want to see whether or not emails that are spam differ from 80% for this man's company. Now, yeah, I know up here they gave you this 89%. Sometimes they just give you extra information. That was the spam back in July 2010. It was 89%, and oftentimes that would be what we would use in our null and our alternate statement, because it would probably be related to the claim. But if you look in the claim, they used 80%. So we're saying for our claim that the proportion is equal to 80%. I'm going to go ahead and put 0.80. That's what I'm going to have to put in the calculator, so I'm going to go ahead and change it. And then proportion, what sign would we use for our alternate statement? So let's read the claim statement again. Can you conclude that the percentage of emails differs? So differs would be not equal to. All right, so which type of test are we running? We are testing a percentage, which is a proportion, so that's 1 prop z test. And we have to put in P0, which we already said was 0.80. We have to put in X. We have to put in N. X is the number of emails that were spam, which was 382, and 500 was the total number of emails. Okay, and then you want to make sure that we choose not equal to. Okay, so pull up the calculator. I'm going to go to stat, test. I'm going to choose number 5, 1 prop z test. The P0 should be 0.80. X should be 382. N should be 500. We should choose not equal to. This is a two-tailed test because it's not equal to. And it looks like our test stat would be negative 2.01. But we don't really need that for making our decision the way we make it. We make it using the p-value. So the p-value is 0.0442. 0.0442. So we have our p-value. We need to compare it to our significance level of 0.05. It is less than 0.05, because the zeros are equal, so we move to the 4 and the 5. 4 is less than 5, so 0.0442 is less than 0.05, which means we reject the null. And because we reject the null, that means that there is enough evidence to conclude that the percentage of emails that are spam differs from 80%. And if you had completed a 1 prop z interval to find the confidence interval, you would have found that the confidence interval 80% would not have fallen into it, because to agree with our conclusion, that means that it would have to be different than 80%. Okay, next we have example 9. This is going to be our last example that we work in the video. Children with cell phones. A marketing manager for a cell phone company claims that more than 35% of children aged 10 to 11 have cell phones. I'm going to go ahead and mark this now, because I noticed it at the beginning. This is definitely our claim. That the manager is claiming that more than 35% of children have cell phones that are aged 10 to 11. So in 2009, a 2009 survey of 5,000 children aged 10 to 11 by MediaMark Research and Intelligence, 1,805 of them had cell phones. Can you conclude that the manager's claim is true? Use a 0.01 level of significance. So our null, we're testing a proportion. We're going to say that it equals 35% or 0.35, and for the alternate statement, it's going to match the claim that it is more than 0.35. All right, so we're going to do a 1 prop z test, and our null is equal to 0.35. Our x is the number of children that have cell phones in the survey, so that's 1,805. N is the number of children in the survey, which was 5,000. And the last thing we want to click is the greater than sign, and do that. Okay, I've pulled up our calculator, so we're going to hit stat. We're going to go to tests. Oops. And we're going to choose number 5, 1 prop z test. We're going to put in 0.35 for 35%. There was 1,805 children who had cell phones. There were 5,000 children surveyed. We are making the claim that it is greater than. And it looks like our p-value is 0.0515. 0.0515. Okay, our p-value is 0.0515, if I remember that correctly. Our confidence, or I'm sorry, not confidence, our level of significance is 0.01. So this is definitely greater than 0.01, and because of that we fail to reject the null. If we can't reject the null, that means we don't have enough evidence to support the conclusion. So for our conclusion statement, there is not enough evidence to conclude that more than 35% of children aged 10 to 11 have cell phones. Now, if I were to ask you to do a confidence interval, you would do a 1 prop z interval and pretty much enter the same info. And in order for it to agree with what our conclusion said, because we said there's not enough evidence to conclude that more than 35 have cell phones, that means that it's possible that it is 35% that have cell phones. So in order to agree, our confidence interval would contain 0.35, because that would show that it wasn't greater than 35. All right, that's all we're going to do. I know that there are quite a few other examples. I'm going to leave these for you to practice because that's how you're going to get better at this, is practicing. So I think you have examples 10 through 18 that you can practice and work on. All right, so let me know if you have questions.